So we've been talking about surface temperatures, and I kind of want to revisit this idea of surface temperatures, how they change as the Earth spins on its axis in one day, as the Earth rotates. The sun is highest in the sky directly at noon, and when it's highest in the sky, it has its largest angle. And actually, kind of like we talked about before in this unit, when the sun has with a great angle comes less beam spreading and less beam depletion. Okay, so and so as the sun is low on the horizon at either sunrise or sunset, we say the angle is less and that it makes with the horizon, and so and it has a lot of atmosphere that it needs to go through, and so it has a lot of beam depletion, and when it hits the Earth's surface, it's kind of spread out a large area, so it has a fair bit of beam spreading. So therefore, we just generally have less energy ultimately getting to the Earth's surface. So there's this phrase called lag of maximum. And what they're saying there is the lag of the maximum surface temperature relative to the maximum incoming solar radiation. Remember I said at noon the sun has the largest angle, so we have the most amount of solar radiation coming in. But there's a lag, and it's about 2 to 3 to 4 hours after noon is when you're going to get your hottest daytime temperatures. And I'm going to show you a graph here in a minute to kind of describe why this is a lag of maximum surface temperature lagging behind the maximum incoming solar radiation. And the reason we have a delay in our maximum surface temperature from noon, it has to do with the Earth kind of oozing its solar radiation out. And it kind of, you'll see what I mean. It's at its peak, that oozing, that re-radiation is at its peak delayed about maybe 3 hours after noon. So what you're going to see on the next slide is the minimum daily temperature is always right before the sun rises. It's funny, if you've gone camping before, I just think that right before the sun rises, you're shivering in your tent. It's just the most terrible cold. And then the maximum temperature is, like I said, about maybe 3 p.m., 3 or 4 p.m. Now, clouds will definitely play a role. Clouds will have a cooling effect when the sun is out, and clouds will have a warming effect most certainly when it's nighttime. So what you're going to see on the next slide is assuming that there are not clouds. I think this is really pretty good. The pink line, or the red line, is showing you as the sun rises. They're kind of just a typical sun rising at 6 a.m., sun setting at 6 p.m. Looks like an equinox sort of situation. And it maxes, the incoming solar radiation maxes at noon. Now, the blue line is showing you the Earth oozing or re-radiating its thermal energy. So notice that it is minimum also about 6 a.m., but notice this re-radiation peaks about, maybe 3:30 p.m. Okay, so that's the re-radiation, is the blue line. So the net effect is shown below. This purple line down here is showing you kind of a typical kind of a swing in temperature from the coldest temperature right before sunrise, or right at sunrise, and the warmest temperature mid to late afternoon. So, you might have run into this before, in that actually it's at noon that you're going to have the most incoming solar radiation, so maybe you'll get most sunburnt then, I don't know. But actually the hottest surface temperatures are lagging behind that. So it's kind of a practical sort of thing. So this is a thermograph, just kind of showing you can kind of almost see the 24-hour cycles. But I kind of wanted to take you to this new website. If you have a chance and you're kind of taking notes as you're listening to this slide, you might want to jot down something called weatherspark.com. And I'll try to remember to go ahead and put it under the different websites you might go to get weather information. but check this out. And I haven't played around with it a whole lot, but I really like it. And when I saw that thermograph that kind of recorded the temperatures, I really thought about this website. Check it out. So again, I'm sure there's all sorts of bells and whistles that I'm not familiar with. But if you can make out the color here, actually this black line over here is showing you the temperatures as they rose and fell today. And then this blue line are the forecasted temperatures. And also up here, we kind of have some like little icons of clouds and sun, etc. It is just so cool. I also really like this, and it may be kind of too small for you to see, but can you see where it has the mean temperature for this time of year for this location? This happens to be Burlington. And then it kind of shows you extremes. So what I'm thinking is you can use this to get historic data. So like I can go back, and that's all historic data. And it's kind of fun to, I just think it's neat. And for some of you, like if you're filling out your weather log and you're trying to get 3 a week, 3 total weeks of data, this might be kind of helpful. Just you'll have to get on and play around with it. Under graphs, you can also change and add pressure. That's kind of fun to see pressure rise and fall and see what kind of consequences it has. So pressure is down here. It is just a really neat website. So I was glad to find it. Let's see. I have lost. Just want to kind of show you a few more slides. Okay, so the minimum temperature is about sunrise, around the equinoxes. That would be for us about 6 a.m. One of the things we're going to talk about in a later chapter is this idea of conditions that will cause some sort of condensation or some sort of solidification of water. So what you're seeing here is frost, solidification of water, right? And one of the ways you can get solidification of water is by dropping the temperature. So around sunrise, the coldest temperature, it's not so surprising that that's when you're going to oftentimes get frost. One type of fog called radiation fog is actually very much favored at this coldest time of the day around 6 a.m. Well, depending upon, I should say around sunrise. So sunrise sure can vary, can't it?